This is 6.2, factoring trinomials. In 6.1, we talked about factoring out a greatest common factor, and we talked about factoring by grouping. So if you look at the factoring guide we had, we factored out the GCF if we have one. This is still always our first step, okay? And then where we were in 6.1, we had 4 terms, so we tried factoring by grouping. Where we're going to be now is, so do you have 4 terms? No. Do you have 2 terms? No. We're going to have 3 terms. And we don't know yet our special cases, so we're actually ending up right here. Use one of the methods in section 6.2, okay? The rest of this are special cases, which we will cover in 6.3. Okay, so there are 2 main types of factoring trinomials. The first type is when the number in front of your square term is a 1. That's the easiest case. The other kind is going to be when you have a number other than 1 in front of your square term. Okay, so first of all, when we have a 1 in front, this is the easier case. What we're going to look for is we are looking for 2 numbers that multiply to a negative 24 and add to a 2. Okay, so we want numbers that multiply to a negative 24, and then when you add them together, you get a positive 2. Now let's think for a second. If we're multiplying and we get a negative number, that means we have 1 negative and 1 positive. It's the only way that can happen if we're multiplying 2 numbers together and get a negative answer. One's positive, one's negative. And if they're supposed to add to a positive number, then the positive should be bigger than the negative, so that when we add them together, we get a positive number. Okay, so that's just sort of things to keep in mind. What I'm going to do first is I'm just going to list everything that I can think of that multiplies to 24. I'm not going to worry about the sign in the beginning. And I'm going to go in order. Now, I know 24 is a relatively small number. You can probably do this in your head. But what I'm about to do will help a whole lot when we get to the other type of problem where we're dealing with much bigger numbers. Okay, so things that multiply to 24. 1 and 24. I'm going to go in order over here. 2 and 12. 3 and 8. 4 and 6. The next one I would try is 5. 5 does not divide evenly into 24, so I don't write it down. And then the next one I would check is 6, and it's already written down. Basically, you're going to go in order, and then eventually you're going to find that you've wrapped around. Like you've already got a number written that you need. And then once you wrap around, you have every possibility listed. Okay, now I want some that add to a 2, knowing that one of these is a negative. It looks to me like if I take the 4 and the 6, and I make the 4 a negative number, that will multiply to a negative 24, and when you add them together, you get a positive 2. Okay, so we have our answer here, we just don't realize it yet. What we get to do is we're going to write this as 2 binomials multiplied together, and make sure you use the correct variable. This is z, so I put a z here, and I'm going to put a z here. Now what numbers go here and here? A negative 4 and a positive 6. So this factors as z minus 4 times z plus 6. And this is the same as z plus 6 times z minus 4. And the reason for that is we're multiplying 2 things together, and you know that it doesn't matter what order we multiply in, we're going to get the same answer. Okay, so let's try negative p squared plus 6p plus 27. First thing you need to know is it's always easier if your first number is positive. Okay, so right here I have a negative in front. What we can do is we can factor out a negative 1. which basically just changes the sign of everything. If I factor out a negative 1, what I will have left is p squared minus 6p minus 27. If you think about distributing that through here, it's going to give you this back. Okay, now normally we don't write a -1. Normally we just write the negative because mathematicians are lazy, and if we can get away without writing something, we do. Okay, so this is basically a traveler. It's going to follow us down. We can't lose it, but we never really have to think about it again. What we have now is a trinomial with a 1 in front of our square term. So what we want to do is we want to look for two numbers that multiply to this, to a -27, and I want them to add to a -6. Okay, now I'm going to list things that multiply to 27, ignoring the sign for a minute. I have 1 and 27, 2 does not work, 3 and 9, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 doesn't work. The next one that does is a 9, and it's already listed. Okay. All right, so these are my possibilities. They need to multiply to a negative, so that means I'm going to have a positive times a negative or a negative times a positive. Okay. They add to a -6, so that means my bigger number is the -1. So where can I get a -6? Right here. If I make that a -9, if I multiply these together, I do get -27, and when I add them together, I get -6. Always take the extra time to make sure you've got your signs correct. It's very easy to mess that up. Okay, so I still keep this negative. My variable is a p plus 3 times p minus 9. And of course, this is the same as -p minus 9 times p plus 3. It doesn't matter which binomial you write first. Okay, so let's try k squared minus 11hk plus 28h squared. Okay, so this one has an extra variable in it. It's really not hard to deal with. It's not hard, you've just got to remember to do it. I'm going to go through the same basic process I did before, but when I go to write my answer, like I did right here, it's going to be k, and then I'm going to have plus or minus a number here, and then I'm going to have an h at the end, and then the same thing, something, and an h at the end. So it's going to be like this. It's just going to put a variable after the number. Okay? So basically, for right now, let's pretend that h squared isn't even there. I would be looking for two numbers that multiply to a positive 28 and add to a negative 11. Now, if I'm multiplying to a positive number, that either means I'm multiplying a positive times a positive or a negative times a negative. Okay. Now, if I am multiplying two positives together and I go to add them together, I'm never going to get a negative 11. I'm not going to get a negative number. So both of these need to be negative in order to multiply to a positive and add to a negative number. Now, what I'm going to do is I'm going to list things that multiply to 28. 1 and 28, 2 and 14, 3 doesn't work, 4 and 7, 5 doesn't, 6 doesn't, and then you're at 7. Okay, so I'm going to make both of these negative. Which one of these adds to 11? Well, -4 and -7 multiply to a positive 28, and they add to a negative 11. Okay, so when I write my answer, I have k minus 4, and then put that h on the end, times k minus 7, h. Put that h on the end. Now think about multiplying this back together. Ideally, you go through a complete check. You multiply it all the way out to make sure that you end up back here. But you can just check your sign, your variables here. If I multiply these two together, I'm going to get a k squared. If I multiply these two and these two, I'm going to have that hk. And if I multiply these two, I'm going to get the h squared. Like I said, ideally, you go through a complete check to make sure you're 100% correct. But this is your answer here. Just make sure to put that h in there, and you are going to be good. Okay, so let's look at this problem right here. P squared minus 5p minus 18. My coefficient in front of my p squared is a 1, so it's still this first possibility. I am looking for two numbers that multiply to a negative 18 and add to a negative 5. So let's list things that multiply to 18. I'm ignoring the sign for a step. 1 and 18, 2, 9, 3, 6, 4 doesn't work, 5 doesn't work, and then you're back at 6. Okay, so if I'm multiplying to a negative 18, that means I have a positive and a negative. Okay, and then if I'm adding to a negative, that means my larger number is the negative. So it would be one of these. And add these together, you get negative 17, not negative 5. Add these together, you get negative 7, not negative 5. Add these together, and you get negative 3, not negative 5. None of these work. So what does that mean? What do we do? Okay, if you're following this, of course, understanding that we don't know all these properties yet, I factored out a GCF if we have one. Well, the coefficient here is a 1, and so no number will factor out. This one has a p squared, this one doesn't, so there's no GCF to factor out. Okay, we did not have 4 terms, we did not have 2 terms, we had 3 terms. Okay, don't worry about this yet, we don't know that, we got stuck right here. Use one of the methods in 6.2. And then after you get that, you come down to here. And you were asked, basically, were you able to do anything? Were you able to factor out our GCF? No. Use factoring by grouping? No. Difference of squares, perfect square, trinomial sum, or difference of cubes, those are all ones we're going to learn in a minute. 6.2, no. We weren't able to do anything, so we have a prime polynomial. Okay, now that means we cannot rewrite this thing as a multiplication problem.